Okay, continuing with 15.1. My battery died on me, so I have to kind of finish this with a separate video. Now we were looking at number 5 on page 447, and I shown you one way to do that kind of a problem, and here's another way. So if I've got 4 equals 130 divided by r plus 20. Now what I'm going to do is I'm going to put a 1 underneath that 4, just sort of as a placeholder so you can see it. Now, what I can do to both sides of an equal sign, I can invert both sides. So this can become 1 over 4 is equal to r plus 20 over 130. And that puts our unknown, our variable, in the numerator. To continue this thought, I would multiply both sides by 130, and this becomes a 1. So multiply this side by 130, or 130 over 1. So 130 times 1 is equal to, let's write this, let's write it right here. 130 over 4 equals r plus 20. Now I need to multiply the 4 out. So this becomes a 1. So multiply this side by 4. I'm going to go ahead and distribute that. So 130 equals 4r plus 80. And so subtracting 80 from both sides, you might recognize this already as what we did before. You're always going to end up getting to the same spot eventually anyway, if you do it properly anyway. So 130 minus 80 is 50. 50 equals 4r. Divide both sides by 4. And we get the same thing that we had before. R equals 50 over 4. You can write it like that, or you can write it as a decimal, which is 12.5. Now, the other way, the last way I'm going to show you to do a problem like this is probably, I'd say probably the best way, because it has to do with proportions. So 4 equals 130 over r plus 20. Now I'm going to put a 1 under there again, but this time what I'm going to do is I'm going to cross multiply. 1 times 130 is 130 equals 4 times that. So 4r plus 20. And then of course you can see what's going to happen here. 130 is equal to 4r plus 80, and we're right back to where we were right up here. So once again, subtracting 80 from both sides, I get 50 is equal to 4r, and divide by 4 again. This is a better way to do it. If you have your unknown in the denominator. Now the reason why this is a better way to do it is because we're going to be doing more proportions as we go along. In setting things up as a proportion, meaning that two fractions are equal to each other and we cross multiply, it's a good technique to use for many different things. So this would be my preferred way of doing this kind of a problem right here. Okay, so let's see what else we have in here in this topic. Let's see, power up. Oh, look at number 24 on page 448. They're throwing these at you. So this is 2h squared minus 20 is equal to, in parentheses, h plus 4 times h minus 4 conjugates. Okay, so we have two binomials in parentheses we're multiplying. Now we haven't done one of these yet. This is similar in some ways to distributing, but what I'm going to do is I'm going to use what's called the FOIL method. I'm going to multiply the firsts, then the outers, then the inners, and then the lasts. So far this side stays the same. Now I'm going to multiply the firsts. H times h is h squared. Then I'm going to multiply the outers. H times a negative 4 is a minus 4h. And then I'm going to multiply the inners plus 4h. And then the lasts. Positive times a negative is a negative. 4 times 4 is 16. We have these middle terms will cancel each other out. So what we're left with is 2h squared minus 20 is equal to h squared minus 16. Then to continue this, I personally would add 20 to both sides and subtract h squared from both sides. And what I would end up with, on this left side, I would have just 1h squared. And then on the right side, I would have 4. And now, I would take the square root of that and the square root of that, and I would get h is equal to the square root of 4 is 2. Ta-da! So, the FOIL method. That's a new thing. Now, you may have done it in another class, but for us, we haven't done that yet. Oh, I think that most of the others are pretty much the same kind of stuff that we've done. So that is 15.1.